Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civi, and today I'm going to discuss estimating NC using AHRI standard 885. A little while ago we discussed sound power in NC, but what I didn't really get into is how NC is calculated. Catalog NC is not a measured number. It's calculated from the unit sound power using AHRI standard 885. Now you can actually measure sound pressure by taking a sound meter into a room and taking readings, but for catalog data, NC is a calculation. It comes from subtracting accepted sound attenuation factors, determined by AHRI 885, from the tested unit sound power numbers, which are measured in a reverberation room. This will give you an estimated sound pressure, which you then can plot on an NC chart and get NC. AHRI 885 is titled Procedure for Estimating Occupied Space Sound Levels in the Application of Air Terminals and Air Outlets. It's full of tables for radiated and discharge sound attenuation. It also defines NC and RC and has a table showing acceptable sound levels for different types of spaces like open plan offices, hospital rooms, private offices, and so on. Using the tables in AHRI 885, you can find your installation characteristics and subtract their attenuation factors from the unit sound power to estimate the room sound pressure and calculate the NC. So let's look at one of the tables. This is table D14, uncorrected ceiling space effect attenuation values. So what you can see are there are different types of ceilings, mineral fiber, glass fiber, at different densities, thicknesses, and weights. And then by octave band, the attenuation values for them. So you can see on this first row on type 1, mineral fiber, 20 pounds per cubic foot, you have 13 dB reduction in the 63 Hertz band, 16 in 125, 18 in 250, and so on. The only thing between a VAV box radiated sound and the occupant is usually the ceiling. So knowing how much the sound the ceiling attenuates is very important. All you have to do is select the ceiling type you're using and subtract the attenuation from each octave band. Let me make a little room here. So let's say this is the radiated sound power value of the VAV box you have by octave band. 72, 66, 59, 54, 48, and 45 in the 7th band. So we go up to the ceiling table and look at the 20 pounds per cubic foot and 0.63 inches thick ceiling, you see these attenuation factors. By subtracting the table values from the sound power, you get these values: 56, 48, 39, 28, 17, and 9. There's one more line we need to subtract from all the sound power data. It's called the environmental effect, and it looks like this. The environmental effect results from calibrating the reference sound source that we use to test the data in an anechoic chamber, but using it in a reverberation room. The environmental effect is subtracted from both radiated and discharge sound powers. So now let's subtract our environmental effect and we get 54, 47, 39, 28, 17, and 9. This is our calculated room sound pressure. Okay, so let me make a little more room here. Now you can plot this last number on an NC chart and come up with the NC. So I'm going to pull up an NC chart here. Let's put it down here. Okay, so let's try to plot this. We have 54, 47, 39, 28, 17, and 9. If I kind of draw a line through that, you see, well, I didn't draw a great line, but this comes up essentially as an NC 37. And so this was for radiated sound. Now you can basically do the same thing for discharge sound. There's just a lot more attenuation factors involved. You can have ductworks, there's tables for square and round, lined and unlined, elbows, T's, flex duct, and many other tables. You can get really specific about your application. Now you probably don't need this for every project, but there's sometimes when it is important. Make a little room here. So you're probably not going to need to go into this level of detail for all applications. But if you think back to the ceiling application we discussed earlier, the attenuation for the ceiling type we picked was 16, 18, 20, 26, 31, and 36. So ceiling makes a big difference in an application. If you have a project that does not have a ceiling, then the catalog sound numbers wouldn't be accurate for your application. So you'll want to calculate the NC of your application without the ceiling attenuation numbers to get the most accurate NC for your design. Applications with no ceiling or unlined ductwork are probably the two most common applications where we recommend doing the calculations so that you know exactly what you're going to get acoustically in your project. Luckily, you don't have to do this by hand. Selection software such as our Teams selection program will calculate this for you. It'll allow you to change your ceiling or your ductwork type in your project and run the calculation and selection with those numbers. So everything you put into your installation will affect the sound of your application, but you can calculate this using AHRI 885 tables. So that's how you calculate NC using AHRI 885. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.